Listen to part of a lecture in a biology class.
Okay, now I want to talk about an animal that has a fascinating set of defense mechanisms, and that's the octopus, one of the unusual creatures that live in the sea. The octopus is prey to many species, including humans. So how does it escape its predators? Well, let me back up here a second. Anyone ever hear of Proteus? Proteus was a god in Greek mythology who could change form. He could make himself look like a lion or a stone or a tree, anything he wanted, and he could go through a whole series of changes very quickly. Well, the octopus is the real-world version of Proteus. Just like Proteus, the octopus can go through all kinds of incredible transformations, and it does this in three ways: by changing color, by changing its texture, and by changing its size and shape. For me, the most fascinating transformation is when it changes its color. It's a normal skin color. The one it generally presents is either red or brown, or even gray, and it's speckled with dark spots. But when it wants to blend in with its environment, to hide from its enemies, it can take on the color of its immediate surroundings: the ocean floor, a rock, a piece of coral, whatever. Charles?
Do we know how that works? I mean, how they change colors?
Well, we know that the reaction that takes place is not chemical in nature. The color changes are executed by two different kinds of cells in the octopus's skin, mainly by color cells on the skin's surface, called chromatophores. Chromatophores consist of tiny sacs filled with colored dye. There might be a couple hundred of these color sacs per square millimeter of the octopus's skin, and depending on the species, they can come in as many as 5 different colors. Each one of these sacs is controlled by muscles. If the muscles are relaxed, the sac shrinks, and all you see is a little white point. But if the muscles contract, then the sac expands, and you can see the colors. And by expanding different combinations of these color sacs to different degrees, the octopus can create all sorts of colors. Yes, Elizabeth?
And just with various combinations of those 5 colors, they can recreate any color in their environment?
Well, they can no doubt create a lot with just those 5 colors, but you're right. Maybe they can't mimic every color around them. So that's where the second kind of cell comes in. Just below the chromatophores is a layer of cells that reflect light from the environment, and these cells help the octopus create a precise match with the colors that surround them. The colors from the color sacs are supplemented with colors that are reflected from the environment, and that's how they're able to mimic colors with such precision. So that's how octopuses mimic colors. But they don't just mimic the colors in their environment, they can also mimic the texture of objects in their environment. They have these little projections on their skin that allow them to resemble various textures. The projections are called papillae. If the octopus wants to have a rough texture, it raises the papillae. If it wants to have a smooth texture, it flattens out the papillae, so it can acquire a smooth texture to blend in with the sandy bottom of the sea. So the octopus has the ability to mimic both the color and the texture of its environment. And it's truly amazing how well it can blend in with its surroundings. You can easily swim within a few feet of an octopus and never see it.
I read that they often hide from predators by squirting out a cloud of ink or something like that.
Yes, the octopus can release a cloud of ink if it feels threatened. But it doesn't hide behind it as is generally believed. The ink cloud it serves to distract a predator while the octopus makes its escape. Now, there's a third way that octopuses can transform themselves to blend in with or mimic their environment, And that's by changing their shape and size, well, at least their apparent size. The muscular system of the octopus enables it to be very flexible, to assume all sorts of shapes and postures. So it can contract into the shape of a little round stone and sit perfectly still on the sea floor. Or it can nestle up in the middle of a plant and take the shape of one of the leaves. Even Proteus would be impressed, I think.